In a universe of seemingly infinite scale and countless wonders, it's strange that the thing we're most desperate to find is ourselves. Just 40 light years away, in the quiet constellation of Aquarius, lies a tiny red star called TRAPPIST-1e cold, ancient, barely glowing like a lonely candle flickering in the dark. And yet, around that fragile flame, nature performed a miracle's 7 rocky worlds, each nearly the size of Earth, all circling a single fading sun. It's as if the universe itself wanted to ask, can life exist here? In the dim glow of a dying star, one by one, scientists crossed the others off the list too hot, too cold, no air, no chance. But one remains, TRAPPIST-1e, the last world still whispering a possibility. And now, for the first time, James Webb has looked closer than ever, and what it saw, scientists can't quite explain. A signal, faint, but impossible to ignore. Was it just starlight, or something trying to breathe? The TRAPPIST-1 system is unlike anything we've ever seen. 7 worlds, all rocky, all close in size to Earth, packed tightly around a dim red star. From a distance, it looks almost like nature's own experiment. 7 variations of the same planet, orbiting the same faint sun, each one rewriting the rules of habitability. The star itself, TRAPPIST-1, is barely bigger than Jupiter and glows with a light so faint it would take 1,000 of them to match our sun. Yet somehow, this tiny ember became the richest neighborhood of Earth-sized worlds ever found. Astronomers call it a red dwarf small. Cool. And long-lived. The kind of star that burns slow, but burns forever. That makes TRAPPIST-1 the perfect laboratory to test one question humanity has asked for centuries: can life exist around a star so weak, so cold, so unlike our own? Because if life can survive here, it changes everything we thought we knew about where life can begin. If there's life out there, it might be looking back from a sky lit by a red sun. But for life to exist, it needs more than light. It needs protection. And that's where the story gets wild. TRAPPIST-1e orbits its star incredibly close, just 1/13th, the distance between Mercury and our sun. That means a year there lasts just over 6 Earth days blink. And an entire season has passed. At that range, gravity plays a cruel trick. The planet is tidally locked. One face forever staring into daylight, the other trapped in endless night. On the dayside, temperatures could melt metal. On the night side, the air itself might freeze solid. But between those two extremes, where the light fades into shadow, lies something extraordinary. Astronomers call it the twilight band. A thin, eternal strip where day meets night, and where the balance might just be right. Imagine standing there, a red sun frozen at the horizon. Half the world burning, half the world asleep under stars. It's a world balanced on a knife's edge, where one small change could mean survival or extinction. And if that twilight band can hold onto an atmosphere, it might just be the most valuable real estate in the galaxy. When a planet crosses in front of its star, a tiny bit of starlight filters through whatever air that planet might have. James Webb captures that faint light and splits it apart like reading a cosmic fingerprint to see what gases are hiding there. Every molecule leaves its own marked carbon dioxide. methane, water vapor, each one carving a tiny dip in the spectrum. And by measuring those dips, scientists can tell if a world has air, and maybe even if that air could support life. One of the first research groups given guaranteed time on Webb was called DREAMS, short for Deep Reconnaissance of Exoplanet Atmospheres through Multi-Instrument Spectroscopy. Their mission was simple but ambitious. Aim the telescope straight at the TRAPPIST-1 system and search for signs of atmosphere. Webb's NIRSPEC instrument, the near-infrared spectrometer, became their most powerful tool, sensitive enough to read the chemistry of a planet 40 light-years away. Each dip in that light curve, it's like catching a planet breathing. And what they found on TRAPPIST-1e wasn't nothing. It was a whisper of something alive. So here's what it's not. No fluffy hydrogen atmospheres. No thick choking carbon dioxide clouds like Venus. And no thin ghost air like Mars. Good. Because none of those could support life anyway. James Webb's data ruled them out one by one, stripping away the unlikely until only the possible remained. Think of it like a detective story. Every spectrum, every missing wavelength, another clue about what kind of air this world might breathe. Scientists now believe TRAPPIST-1e doesn't have the original hydrogen-helium envelope. It was born with the star's early radiation, likely stripped that away long ago. It also doesn't seem to have a Venus-style carbon dioxide blanket, or a Mars-style whisper of air. So what's left? Something heavier. Something stable. Maybe something closer to home? Each wrong answer brings us closer to the right one. And that right one might look surprisingly familiar. Imagine an atmosphere made mostly of nitrogen, thick enough to carry warmth from the blazing dayside to the frozen dark. Beneath that air, oceans could shimmer beneath a red sun, steam rising where light fades into shadow. The numbers even line up surface pressure close to 1 bar, about the same as Earth's, and enough heat circulation to keep the planet's hidden side above freezing. It would be a strange kind of balance, a world divided by light and darkness, yet held together by air from orbit. You'd see a half-lit planet one side burning with orange glow, the other silver with ice and cloud. Maybe storms circle the twilight line, feeding off the constant clash of heat and cold. It's haunting, but beautiful. A world that might just breathe like ours. But then the data turned, and what it suggested next flipped everything upside down. Turns out, too much methane can actually cool a planet. The gas traps heat before it ever reaches the surface, bouncing it right back into space. The result? A planet that glows red but stays cold, a mirror that reflects its own warmth away. That means the only place where water could remain liquid might be right along the twilight line, the razor-thin border between day and night. A world split in two, half frozen, half burning, and in between, a narrow ring where life might cling to survival. Scientists call it Terminator habitability, the idea that life could survive in eternal dusk. Balance between fire and ice? It's harsh, but possible. The kind of place evolution might turn desperation into adaptation. And yet, that twilight zone might be exactly where life first sparked, just like Darwin's warm little pond. Stand with me on TRAPPIST-1e. Look up. The star fills half the sky. 4 times larger than our sun. Glowing deep orange. Oh, it's beautiful. But deadly. Every few days, The star erupts massive flares tearing through space with the force to strip a planet bare. The most powerful solar storm ever to hit Earth, the Carrington event in 1859, happens here every 2 days. For a planet like TRAPPIST-1e, that's the ultimate test. Either its magnetic field shields it, or it dies. Maybe somewhere beneath its surface. Molten iron still churns, creating a shield like Earth's, holding the air in, keeping the dream alive. And scientists aren't done watching. James Webb still has 15 more transits to observe, 15 more chances to see if that breath of life is real. Maybe by 2041, when the Habitable Worlds Observatory launches, we'll finally know if this world ever truly breathed. Until then, it remains a question, a heartbeat. We can't quite hear pulsing somewhere beyond the red light. So, tell me, which side do you believe in? The living twilight or the frozen void? Stay curious. Stay critical.